Hello, welcome to Chapter 5, Electrons and Atoms. Homework help. It's November 3rd, 2014, and we're going to work on these problems in sections. The first section is the front. So let's find, first question, let's find the energy of one quantum of orange light if orange light has a frequency of 4.8 times 10 to the 14 hertz. So we're going to get our equation E equals hv. Now plug the numbers in. I have Planck's constant 6.626 times 10 to the negative 34 joules seconds. I'm going to multiply that by 4.8 times 10 to the 14 hertz. Seconds cancel out and I'm left with joules. So now I'm going to do 6.626 times 4.8. That gives me about 32. This 32 I am going to hold on to. I have then also negative 34 and 14. I'm going to add negative 34 and 14. That gives me negative 20. This I know is not correct scientific notation, so I'm going to move my decimal point. So I'm going to have 3.2 times 10 to the negative 19 joules. It's that easy. Number 2. Number 2 is asking which is greater, the energy of one photon of orange light or the energy of one quantum of radiation having the wavelength of 3.36 times 10 to the negative 9 meters. So I'm going to get my equation. C is equal to lambda V. I'm going to rearrange it to give me V frequency. So I'm going to have V is equal to C divided by lambda, just wavelength. So then I'm going to plug it in. I'm going to have 3.00 times 10 to the 8 meters per second. I'm going to divide that by 3.36 times 10 to the negative 9 meters. Meters cancel out. I'm left with per second. That's hertz. And you plug this into a calculator, you get 8.93 times 10 to the 16 per second. This I'm going to multiply by Planck's constant of 6.626 times 10 to the negative 34 joule seconds. Seconds cancel out. So I'm left with joules, giving me energy. When I multiply these, I get 5.92 times 10 to the negative 17. So the photon of orange light has less energy than the quantum of radiation, having a wavelength of 3.36 times 10 to the negative 9 meters. Number 3 is asking you for the relationship between this equation and this equation, so we can do that to this. And that's all number 3 is asking about. Number 4, sorry about that. Number 4 is a radio station emits a radiation at a wavelength of 2.90 meters. What is the station's frequency in megahertz? So I'm going to get my equation here. V is equal to C divided by lambda. So I have 3.00 times 10 to the 8 meters per second. I'm going to divide that by 2.90 meters. Meters cancel out. I'm left with per second. That's hertz. So this is 1.034 about times 10 to the 8 per second. Now I want megahertz. So mega is times 10 to the 6. I have times 10 to the 8. So I'm going to have 103 times, moving the decimal, I have 8 minus 6 is equal to 2. So I'm moving the decimal 1, 2, or 1, 2. Times 10 to the 0, so I don't have to put anything, megahertz. So it's broadcasting at 103 megahertz. Alright, number 5 is whatever you want to put down. Just my favorite radio station is 88.7. Not really, it's the only station I know. So I'm gonna have the equation C is equal to lambda V. I'm gonna get V alone, cancel that out, and divide both by V. So I have C divided by V is equal to lambda, and the speed of light is 3.00 times 10 to the 8 meters per second. I'm gonna divide that by 88.7 megahertz, or that would be times 10 to the 6. So I can put times 10 to the 6, and you do the math. All right. Number 6, very easy. If you are in one of my classes that has received the cheat sheet, then you have no issues. If your class does not receive the cheat sheet because of the time that I made them, this is the cheat sheet, and it tells you that energy increases as you go this way. So let's see, putting them in order. The largest one I see is 5D. Sorry, 7P is the largest one I see. So you're going to go from here, 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 here. So this is the order in which they should go. 1S, 2S, 2P, 3S, 3P, 4S, 3D. Remember that 4S is more stable or has less energy than 3D. 3D is a weird shape, and you probably don't want to be in a weird shape. Wow. Alright, you want to be in a 4S instead of a 3D. Then you're going to put 4P, 5S, 4D, 5P, 6S, 4F, 5D, 6P, 7S, 5F, 6D, 7P. You might notice that when you go from P to D, you're going to go down one, and when you go from from P to F, you can go down 2. That's just a little hint. Number 7, you look at the problem. It's telling you which element is this. We have krypton, 5s2, 4d10, 5p4. I don't have to look at all this. I can just tell you that in the 5th period, in the p column, the 4th element is tellurium. So what does this mean? Someone took my table. All right. So let's look. We're going to go 1, 2, 3, 4, 5. I'm going to go to the P. I'm going to go 1, 2, 3, 4. The 4th element is tellurium. That's how I do that. You can do that for 8. Now I'm going to skip 8. 9. Very easy. You're looking for valence electrons. There's 2 ways you can do this. We have a neon, 3s2, 3p3. So you can add the s and the p, that's 5. So I should have 5 valence electrons. And 3p, 1, 2, 3 is phosphorus. So phosphorus with 5 electrons, 1, 2, 3, 4, 5. That's how you would do it. Or you can see that the element is phosphorus, and you can count up. You can look up. This is the 5th. So it would have 5, or the 15th group, so it would have 5 electrons because it's 10. It's the number minus 10 will give you the number of valence electrons. And from that you can probably do B and C. So with all those interruptions, this is the first part of the homework.